Okay, well, I'll carry on looking at dry docking with regard to the righting moments and the effective GM of the vessel. When the vessel settles in the dry dock, in the water, until the moment the stern touches the block, there's no effect on the stability at all. But once we touch the block aft, our stability does progressively deteriorate as the water's pumped out. And this is because we get this upthrust, this P force generated at the block, and it has a destabilising effect. So as the water level falls, P increases, and so the heeling moment, this heeling moment that's created, increases, and the righting moment falls. And we could say possibly at some point the vessel will become unstable. It behaves as though the effective GM, if you like, has been reduced. Because what's actually happening is, as the water level is going down, the underwater volume of water that the vessel is pushing out is reducing, therefore our buoyancy force is reducing. And all the time, at the same time as this is reducing, the P force is increasing and creating this heeling moment. So the big risk is, of course, that the net righting moment will become negative before we can secure the vessel on the blocks. And that's why it's absolutely essential to ensure that we have a positive, effective GM at the critical instant. So what we have to calculate is, at that critical instance, what is the virtual loss of GM. We then have to look at that and compare it to our initial GM and ensure that once that's subtracted from our initial GM, we would still have a positive GM at the critical instant. Okay, and that's why we have to calculate what we call this effective GM.